Let me show you what we're going to be creating. We have a tile map right here. Means that the height and width. We can set the border tile type and the fill tile type. We can obviously change those later. Yes, there it is. Hit reset map and it spawns the tiles we need. We need a spawn direction. It's going to be where way the player is going to be facing when they spawn, and our spawn tile is going to be where the player spawns. And we need a camera actor. Modes recently placed camera. Put that right there near the center, and make that face downwards and move it all the way up so we can see everything. And we need to set that. And when we hit play, sorry, I forgot one thing. World settings, we have to set our world settings to the correct game mode. Hit up, right, left, whatever. He keeps moving until he hits a tile that he can't enter, or until he hits a tile and it doesn't force you to move in another direction. For example, if you change these to floor, he can enter them, but they don't force him to keep moving. The ice tiles, however, do. We also have different tiles, change tile type. We have lava and, well, I call it lava, but it's basically just a loose tile. You enter it and you lose. Here, retry, reset the map. And obviously we have a victory tile. Scripted actions, change tile type to win tile. You enter this and you win. I don't know why that happened. We can also interact with tiles, like when we're moving around. So if we have these followable pillars, and with a button up here, change to button. Okay. And we're going to make these buttons affect these followable pillars. You'll notice that right now we can't enter these pillars. Oh, I shouldn't have done that. Alright. We can't enter these pillars. However, when we hit this button, the pillars fall down, and now we can enter. Alright, so let's get started. I'm going to start by making a new project. This is going to be blueprint, and I'm just going to use a blank project. I'm going to call this SHG, create project, and wait for that to finish initializing. Alright. This has nothing to do with the tutorial, I just can't stand these big buttons. So first thing I usually do is go to my, editor settings. And check these buttons. Use small toolbar, enable window animation, and in performance, I show frame rate and memory. You notice right here, nothing's showing up. Hit this, now it shows the frame rate and memory. So we're going to need a couple of things first before we even get started. We're going to need a blueprint structure. I'm going to call this chord. This is just going to be an X and Y. Integer, mean variable, X and Y. Save that. We're also going to need some data structure. This is going to be for different directions. So not data structure, sorry, data asset. Primary data asset. We're going to call this direction. What a data asset is if you ever use Unity, it's basically a scriptable object. It's when you go to miscellaneous data asset, and let's choose direction. This right here is an instance of direction that basically always exists. You don't have to like spawn it into a world or anything. We're going to make one for each direction, so this is going to be up. Hit Ctrl W to duplicate it. We're just going to have one for each direction. Up, down, left, right, etc. This is going to be up, this is going to be down, left, and right. Now you might be thinking, why don't we just use an enum for this? But the reason is because we need our directions to actually have some variables. So in our direction, let's add some variables. This first one is going to be our delta, which is how many tiles we move when we go in that direction. Delta. And it's going to be a chord. I don't know why that didn't say chord. Save that. And where you're going to need our rotation, this is going to be how the player is rotated when we're facing that direction. So rotator, let's call this rotation, and we're going to need our opposite direction. Direction. Sorry, I did not get much sleep last night. Direction, and it's going to be opposite direction. You'll see why we need this later. Compile, save this. So down, for example, our delta is going to be y of -1. Our rotation in the z-axis is going to be 180, and our opposite direction is up. Save that. Finish filling out the rest of these. Left delta, x -1. Z rotation is -90, and opposite will be right. Right delta is +1. Z rotation 90. Opposite is left. Save that. And up delta is +1 in y. No rotation, and opposite is down. Alright. So now we can get started. Let's start by creating our tile map. That's just going to be responsible for spawning our tiles. So blueprint class, we'll make this an actor. This is going to be tile map. Like this. And let's put this in the world somewhere. What are we going to need for a tile map? Well, first we need to know how tall and wide it is. So let's add some variables. This is going to be our width and height. Integer, sorry about width, height. Now, if we look in Unreal right now, if we click on this, we notice that we can't actually modify our width and height. In order to do that, we need to click either on this eyeball right here, or we need to hit Instance Editable, this checkbox right here. If we do that, we can notice that we can now modify this. Unfortunately, right now it can go underneath 0. So just because I can't stand that, I'm going to set the value slider and the range value to 0, 0, 0. Alright, we can also set the defaults. Width, I'm just going to set this to a default of 10 and 10. Actually, yeah, why not? 10 and 10. And we can start spawning our tiles. Well, we need our tile class first, so let's make another blueprint class. It's going to be actor tile, what we're going to be calling it. And our tile is going to need a chord. This is just going to be what x and y it is. Chord. So in our tile map, we need another variable. This is just going to be our tiles. It's going to be an array of our tiles. Tile object reference. There we go. And in order to make this an array, we have to click this circle right here. We need to change it from single variable to array. Unfortunately, Unreal doesn't support 2D arrays in blueprints, so we're just going to fake that. So let's make some helper functions to just save some time doing that, or save some space. This is going to be get or chord to index. It's going to need a chord. Let's call that chord. And it's going to output an integer. There's going to be an index in our array of tiles for where this chord is. Index. Split this. I believe it is, to do this we do y times width plus x. I could be wrong about that. I always get these mixed up, but we'll see. And let's make another function. This is going to be index to chord. This is going to take an integer index, and it's going to output our chord. This one I definitely get messed up sometimes. Get our width, split our chord. I believe for the x it is modulo the width, and for our y it is, sorry, it is our index divided, where is it? Divide. Integer divided by integer, there we go. By a width. Again, I'm probably wrong. So let's make a new function. This is going to be, let's call this reset map. This is going to be where we spawn our tiles. First we have to destroy all our old tiles though. So let's go to tiles, get tile, for each loop. If it is valid, because we don't want the engine to crash, in case there's an empty tile. If it's valid, we are going to destroy it. Destroy actor. And when we're done, we're gonna have to empty our tile, because otherwise it'll still have a bunch of references to null pointers, and that's gonna mess up our index to chord and chord to index stuff. After that, we're gonna do get height, get width. We're just gonna do a for loop through these. So for loop, first index is 0. Last index is gonna be height -1 because it starts at sorry, break this link. It starts at 0. So let's say we have a height of 5. It's gonna go 0, 1, 2, 3, 4, 5. That's 6 numbers, not 5. So we have to do -1 because this for loop is inclusive. Here we go. We're gonna do the same thing for the width. To do our get our x and y's for each of our tiles. What are we gonna do now? Let's spawn our tiles. So let's go spawn actor from class, and I'm going to choose tile. Now we want our tiles to know what chord they are, but we can't do it right now. What we could do is we could take our tile and we can do set chord, but that seems like a lot of trouble considering how we're going to do that for every single thing we want to start the tile with knowing. So if we want our tiles to be able to initialize with certain values, we can go to our variable, make sure that instance editable is checked, and we can check expose on spawn. Compile and save that. And if we notice right here, we can set the chord. So let's split this strike pin. X is going to go in here, Y is going to go in here. And as for our spawn transform, that's what this error is right here. It's invalid. We can just split this to make it not invalid. But our spawn transform location, let's split this actually. We need to change our X and Y because we want them to spawn in a grid, not at 0, 0, 0 for all of them. Now here's the thing about Unreal. For some strange reason, the forward vector, you notice that our player start, it doesn't have a rotation, so it's facing forward, right? To it, forward is X going up and Y going to the right. But when you look at it from the top perspective, it goes X going to the right and Y going down, which is kind of strange in my opinion, but that's just me. I'm gonna go with X going up and Y going to the right, but height is still going this way and width is still going this way. Alright, just to let you know. So what we're gonna do is we're just gonna multiply these int by float times float and times float by the tile size, like how big your tiles are. I personally like, well, actually, For the sake of saving time, I'm just going to set these to 100 because that's the size of the a lot of the meshes in Unreal. So X over here, Y over here. Now we can't call this an editor right now because there's no button to do that. So let's go to our function and hit call an editor. This will make this button appear, reset map, and that allows us to call this an editor. So let's hit this, and we spawn a bunch of tiles at 0, 0, 0. I mean, not 0. At the first tile is spawned at 0, 0, 0, and it goes, you know, it spawns them in the grid. Let's check the chords to make sure they're actually right, because I probably got them wrong. X is 2, 4, 9. Okay, I actually got them right. That's great. Did not honestly expect that to happen. So, if you look at this right now, tile, the first tile, 0, 0, is just called tile. If we go to our tile map and we hit reset map, because this is going to destroy all the tiles, you'll notice that that didn't happen. They did not get destroyed. Why is that? Destroy actor is valid for each tile. It's very strange. I'm not sure why they didn't get destroyed. Oh, duh. Because we never actually added them to our tile, right? So get tile, add, and we'll add tile that we spawn. Let's manually destroy all these now because they're all ruined. They're not in our array, so let's... I forgot there's no delete option here for some reason. And backspace. Reset map. Okay, so 0, 0 is tile 200. And we go back to our tile map. And reset map is now 300. Alright, so that's working perfectly. Sorry. Let's make it so we can spawn different tiles depending on if it's a border or not. So let's make another function. This is going to be is chord on border. Sure, let's call it that. This is going to return a alright, this is going to return a boolean. It's going to be is on border, and we need a chord. This is going to be really simple. We're going to split this. If x equals 0, or if y equals 0, or if x equals the width minus 1, or if y equals the height minus 1, get an OR boolean there, 2 pins, and we just return that. So in our reset map, if we drag this in here, is board on tile, you see that it has an execution pin, and I really don't want it to do that just because it takes up space and it makes our wires more tangled. So if we go back to our is chord on border, we can check the pure box right here, and you notice that it no longer takes up all that space and it no longer has an execution pin. So what we're going to do is let's split this, and we'll send in our x and our y, and that should give us if it's a border tile or not. Let me move some stuff around a little bit, get me some more space. Alright, now what we could do is we could go branch, this is an if statement, and based on if it's a border tile now, we can have 2 different spawn actor tile functions being called. But instead we're just going to use a select node. Select, and based on this bool, we can choose what class to use. Is this returning a... this is returning an actor class, so delete that. When we did that, it changed the spawn actor type to none, so it just thinks it's an actor, so it no longer knows that it needs a chord X, chord Y I'm not sure why it doesn't need an instigator, but so let me change this back to tile really quick just to get rid of these errors. Can I tab? And we'll just have two more variables. This is going to be our border tile type. Get tile class reference and make sure it's not an array. And fill tile type. And we want to be able to edit these in the editor, so let's expose on spawn. So let's drag one of these out, get fill tile type, and we're gonna type select. Here we go. And you'll notice that the return value is this. It's gonna be a tile class reference because we select from a tile class reference. So we're gonna go border on option 1. Here we go, and is border tile we're gonna pass into here into select. If it's true, we will get the border tile type. If it's false, we'll use the fill tile type. Let me destroy this branch right here. Pass this in here. And let's test that. We'll make a blueprint child class of tile. We'll call this one wall. And just to make it so there's a mesh, we're going to add a cube. And let's move it up by 50 so it's sitting on the floor. Let's make another one. This is going to be ice. Add component, plane, and that's already on the floor. Let's really quick make a material for that. Ice, so ice underscore mat. Hold on to 3 and left click to add a vector 3, I think. Like this in base color, and let's make this something like that. Compile and save this. There we go. And back in our ice, we can change our material to ice mat. Now if we go to our tile map, actually let me make sure everything's plugged in first. Yep, got it. Alright, so now we can set our border tile type. This is going to show us all of our tile types. We choose wall for border and ice for fill. Reset map. Boom. We have our borders being the right tile type and our fill being the right tile type. Let me, in our wall, let me get rid of this material just because I don't like it. There we go. I like that a lot better. Anyways, let's close the mat because we don't really need that. If we want our tiles to be children of our tile map, so that we don't have to scroll through all this stuff every time we want to try to find our tile map, when we spawn our tile, we can set the, or not set, attach to actor. And our parent actor is just going to be a self. We're also going to change the location rule to keep world, in case the tile map is not a 000. So let's reset map again, and you will notice that for some reason these tiles still exist. What is going on with that? Hold on. Tile map. Let me make it so we can view our tiles. 0 elements. That's very strange. Let me just draw all these. Okay, attach to actor, add to tiles. I'm not sure why that didn't work. Tile map, reset map, 100 elements. Okay, well now it's working. Yeah, you notice that these are all our underneath tile map. We can do that to expand or let's say shrink the list. I can't think right now. So now that we have our different tile types being spawned, let's work some more on the tiles. What our tiles are going to need is they're going to need to know our neighbors. So neighbors. Let's just make it visible, and we'll set the type to be direction. And it's going to be type of map or dictionary. I call it dictionary in my head. And the other type, the value is going to be a type of tile. So this is just going to hold what which tiles in what direction, or in what direction is which tile. Let's make a new function to update our neighbors, or define our neighbors. So function find neighbors. Sure. Neighbors get, and we're gonna have to get do a for each loop for each direction. So to do that, we could go. Well, actually, we can't go keys because right now there's nothing in it. We could set something in here for, wow, what is this? Oh, it's because I can't see the, there it is. I can't see the key thing. We could set, sorry, we can't add something in here. So, it's like that. So, let's set these up, left, down, and right. So now our neighbors have keys. We can get the keys, and we can go for each and find our neighbor in that direction. However, if we are a border tile, there's not going to be a neighbor over here, so we don't really want a direction in that. We don't really want that to be taking up space in our neighbors. So instead, what we're going to do is we're going to drag off this, and hit make array, and we can delete this. Or actually, first we need to add a direction, otherwise it's going to make an array of nothing and we can't select anything. Here we go, and we can just add the directions here. So up, down, left, right. So for each of these, what we're going to do is we are going to get the get deltas. Remember, this is how many tiles in each axis we're moving when we move in this direction. So get delta, split this, get our chord, split that, and we're just going to add these together. So the delta x plus our chord x, our delta y plus our chord y. And that's going to give us the chord of our neighbor in this direction. First, let's make sure that that chord is actually valid. So in our tile map, let's make another function. This is going to be is chord in range. We're going to take a chord, and we're going to take a bool. Or we're going to output a bool is in range. Also, we're going to make this pure, and we're going to split this. So if x is less than 0, or if y is less than 0, or if x is greater or equal to the width, no wait, greater than width. Actually, hold on, width is, this is 9, our tile size is 10, yeah, so greater or equal to width. Or y is greater or equal to height. Or boolean. Then we're not going to be in range, so let's make a not right here. You could save some space and just do the opposite of these and just return that, return the and, but I, for some reason, didn't do that. So back on our tile, if we need a reference to our tile map. Let's tile map. This is not a dictionary. Tile map. This is gonna be type of tile map, and we're gonna expose this on spawn so that we know, it's tile map, reset map. We can't see the tile map right here. We just right click, refresh nodes. There's the tile map. This is gonna be self. So we got our tile map. We get is chord in range, and we split this. X goes in here, Y goes in here, and we branch. If it is in range, alright, if it is in range, all we're going to do is we're going to get our tile map, get, we need another function, new function, get tile at chord. This is going to take a chord. This is going to return a tile. Tile, chord, and we're just going to get our chord to index, make this pure, also make this pure, and we're going to find our tile at that index. Get tile, get. That's not what I want. Get. And we're going to return this. Oh, that was so annoying. Return this. There we go. Back on a tile map, get tile at chord. I forgot to make this pure somehow. Bravo. And the chord is going to be this. Sorry, split this. Split this. And if that is valid, we're going to tell our neighbors to add the tile we found. Key is the direction we're checking. Here we go. In case you're wondering right away, this is valid. It's just a macro. It takes an input object, is valid. It gets the is valid bool, and it returns the outputs of the branch. That's all this is. We could do exactly the same thing with is valid with the first one and branch. This is exactly the same as this. It's just saving some space by doing this instead. Okay. So in our tile map, after we spawn all our tiles, where is this? So completed. After we're done with this, we're going to, for each loop in our tiles, we are going to find neighbors. The reason we don't do this after we spawn it immediately is because, well, the other tiles won't exist when we're spawning this tile. When we spawn 0, 0, 0 or 1, 0 and 0, 1 are not going to exist. So we have to do it after we spawn all our tiles. Let's make sure that actually worked. So go back to our tile map, reset map, and we look at our neighbors. So up is ice212, that's correct. Down is 196, alright. Right is 205, left is 203. And our corners, for some reason, have that taken up. Why is this? Go to our tile. If chord is in range, if is valid. Oh, it's because in our neighbors we trash this. Hide tab. Let's reset the map again. And our corners only have 2 neighbors. and our sides only have 3. Alright. So that's working. Save this. Save that. Now, let's say we want to replace a tile. Right now we can't do that. So let's make it so that we can. In our tile, what we're going to need is, let's call this new tile type. This is just going to be a tile type. So tile class reference. Let's also expose this on spawn. In our tile map refresh node, and we're just going to send in our tile type. So when ice spawns, it's just going to be ice. When wall spawns, it's going to be wall. And in our tile, let's make another function variable. Sorry, not sure why I clicked variable. No. Delete the variable. New function. Let's call this change tile type. And we're going to check if our new tile type dot is equal to, or not equal to our get class of self. Branch. So if it isn't, we are going to spawn actor from class, and it's going to be our new tile type. Our spawn transform is just going to be our tiles transform because it's already in the right place. Get actor transform. Here we go. Collision. Always spawn. Ignore collisions. Chord is just going to be our chord. Come on. Chord is going to be our chord. Tile map is going to be our tile map. New tile type is going to be its class. And actually, let's make our neighbors also expose on spawn, so we can send in our neighbors as well. Get neighbors. Here we go. Now here's the problem when we do this is, also we have to destroy ourselves. Destroy actor self. Here's the problem with what we're doing right now is that when we, let's say we change this one to a wall, right? It's going to know all its neighbors, but its neighbors are going to think that its neighbor in the opposite direction is going to be the tile we just destroyed. So what we need to do is we need to go through all our neighbors, neighbors, get keys, because we don't want to go through more neighbors than we have to. This is only going to contain the neighbors that we actually have tiles in it. For each, what we're going to do is get our opposite direction. Alright, so we're going to find our neighbor in this direction, get neighbors, find in this direction is valid. And what we're going to do is we're going to tell the neighbor in the opposite direction that that neighbor is going to be our new tile. So, you know, we look at this one, we change this tile type, we go to our right tile, and we're going to tell it that its left tile is the one we just spawned, right? Let's make a new function, actually. Function set neighbor. We're going to need 2 parameters. This is going to be direction and tile. New neighbor. In our neighbors, we're just going to add the direction and new neighbor. You might be wondering why we're not using a function called like replace or something like that. That's because there is no function called replace for maps. If you look at the add node, as a key to the value of the map, if something already uses to provide a key, it is overwritten with the new value. So that's why we're using add instead of some function called replace. What we're going to do here is get our neighbor in that direction, so tell that neighbor to set neighbor. Set neighbor. There it is. The neighbor we're setting is the one in the opposite direction, and our new neighbor is going to be the tile we just spawned. Let's make it so that we can call this in the editor. Definitely is not pure. So let's test this. Change tile type. Oh, fudge. Sorry, I forgot one thing. Here, let me reset the map. Okay. We need to make sure that this is a valid class. Is valid class. Branch. Well, we can just make an and. Alright, now let's try this. So we take our new tile type, change this to wall, change tile type. The neighbors are all correct. Up is 357, right is 350, left 348, down 341. Perfect. And if we look at the neighbors, the left of this one is wall 216, which is this one. Alright. So that works. Let's make it so we can also right click on tiles to change the tile type, because you saw me do it at the beginning of this video. In order to do that, actually we need to edit our editor preferences and go to experimental. This is actually an experimental thing, so if you don't want to play around with any experimental stuff, don't do this. Right here, editor utility blueprints utility. Check this box, that is default. Yep. Right click, go to blueprints. You see we can now make a blutility, and we're going to choose actor action utility. Actor action utility allows us to perform actions on actors in the world. Asset action utility allows us to perform actions on assets in our content browser. At least I think that's what it does. So actor action utility, let's call this change. I don't know why that happened. Change tile type. In here, if we double click it, you'll notice this is all that comes up. There's really nothing here. We can't do anything with it. Instead, we have to right click and choose edit blueprint. And we have to override a function get supported class. Delete this. We're just going to choose tile here. This is going to be the type of class that we can, when we... How should I say this? Okay, so when we're selecting actors in the world, let's say we select all these tiles, right? If we right click, it's going to show up our functions. But if we also select, let's say, our tile map, and we right click, it's still going to show our functions, but it's not going to perform the action on a tile map, because our supported class is only tile. So let's add a new function. This is going to be, I don't know, change tile type, and we're going to need a tile type. Tile class reference new type is valid class branch. What we need to do is we're going to go get, what was it, selection set. There it is. This is going to be all the actors we selected. We're going to go for each cast to tile, because it doesn't know we only need to do this on tiles. As tile, we're going to set the new tile type to be this new type, and we're going to tell it to change tile type. So let's test this. Right, click on these, right click, scripted actions, change tile type. change it to wall. Okay, and it works. Okay. Now to get into the actual player movement. Let's make a new pawn. Blueprint class, pawn. Now, you might be wondering why we're using pawn instead of character, because the character says a character is a type of pawn that includes the ability to walk around. However, we're not actually going to be using the built-in pathfinding and stuff like that, because it's just, this is really simple, and there's no need for any of that. Plus, character comes up with a lot of stuff that we really don't need, like swimming and crouching and all that stuff, and it's just not necessary. So we're going to choose pawn. We're going to make this player pawn. Let's do that. And we're going to need a new, in order for the pawn to be the default type to be spawned, we need to make a new game mode. We'll call this, I don't know, SHG GM game mode. Double click this. We can change our default pawn class right here to player pawn. And where's our player pawn? There it is. In our player pawn, let's add a component just so we can actually see it. I'm going to add a cone so we can see what direction it's pointing. I'm so bad at navigating in here. Move it up a little and rotate it to face forward. Forward? Wait, no. This should be 0, this should be, wait, no, hold on. Oh yeah, this is -90, I think. Hold on, let me check. See if I got this right, because sometimes, well, I just can't think. No, that's not right. So, player pawn, like that. There we go. So rotation of 0 is pointing forward. Let's delete this. So if we hit play right now, you notice that nothing happens because we never actually set our game mode. We can do that in the world settings, change this to SHGGM, or we can go to our edit project settings, maps and modes, and change our default game mode to be SHGGM in case you have a bunch of these levels that use this game mode and you just don't want it to you don't want to have to constantly go to our world settings and change this. So we hit play and we can't see anything still. We hit F8 to eject, however. You'll notice that's our pawn. Yay! Okay. Let's make it so we can actually see it from top actually right now. Sorry, I forgot to do that. We need a... Okay, let me describe what we're going to do first, just so this makes more sense. What we're going to do is we're going to make a... Right now when we start the game, our player controller automatically makes our view target our player pawn, right? But we don't want it to be our player pawn, because if it is our player pawn, then the camera's gonna rotate with us, and it's gonna the view is gonna constantly pan around, and it's just not gonna be great for a top-down puzzle game like this. So instead we're going to make another actor that's going to be our view target. What we could do is in our tile map, we could add a camera and set it to automatically adjust the position and height based off our width and height, so that includes all the tiles. But I'm not going to bother doing that. I'm just going to... Wow, recently placed an... Oh, because that's a different project. Alright. I'm just going to add a camera camera actor to the scene and set that to our view target. Let's rotate this down by -90 and move it all the way up so we can see what's going on. Here we go. In our tile map, let's make a new variable. This is going to be our camera actor. It's going to be a type of camera actor. And in our event graph begin play, we can just get our get player controller set view target with blend. And we'll set that to be our camera actor. What this does is it sort of blurps between our current camera and the target camera, and it's gonna move the view target through those over time. So if we set the view blend time to be, let's say, 5. Oh, we also have to tile map, set the camera actor to be the camera actor. If we hit play, you'll see it's moving the view from our pawn to our camera. We don't want it to do that though. Let's just set this to 0 so it automatically does this. Compile, play. Boom, automatically like that. Great. Now while we're messing around with the tile map, let's also change our player spawn. So player spawn tile and player spawn direction. This is going to be type of direction. Let's also set a default of up, just so we don't have to change it every time. And this is going to be a tile. And we need these both to be instance editable. In our tile map, we can now pick a player spawn tile. We can use this dropper right here to pick an actor from the scene. Alright. So on tile map begin play, we're also going to set our, let's get our player pawn first. Player pawn. Set location to be our player spawn tile. Get location. We're also going to set rotation to be player spawn direction. Get direction. Oh wait, why did I do that? No, it's just get rotation. Sorry. Like I said, I can't think right now. And you notice the player spawn's right here, on top of the tile we selected. If we change the direction to be, let's say, right, voila, he's facing right. Let's change it back to up. Okay, now we can actually get back to our player movement. We are going to need our current tile, so we know where we are. Current tile. There's going to be type of tile. So in begin play, let's also set this to, oh, we're at cast to player pawn, so that it knows it has a current tile variable. Cast to player pawn. Set current tile to be our spawn tile. And let's do the same thing for our direction. Current direction. To be our spawn direction. Now what we're going to do is, when we hit an input, when we tell our player to move, we're going to check to see if our current tile has a tile in that direction, and if we can enter it. And if we can't enter it, then we start moving towards it. Let's set up our inputs first. Project settings and input. Here we go. Okay, we have two options here: action mapping and axis mapping. Action mapping is like a button. You press a button down, it triggers, or also when you release the button, it triggers. Axis mapping, however, is it's a float that's constantly going off. So, for example, in your gamepad, your like thumbsticks, it would return how far along those thumbsticks you're moving. We're just going to use action mappings because, well, why not? We don't really need axis mapping here. So move up, move right, move down, move left. And we set as many inputs as we want. I'm just going to use the WASD, so move up is W, move right is D, move down is S, move left A. Okay, so back in our player one, we're gonna see, we're gonna, what did I just call them? Move up. There we go. We're gonna set what happens when it receives these inputs. Move left, move right. The order doesn't matter, I'm just used to doing it this way. Down, left. And we're gonna do the same thing basically. So I'm just gonna make a custom event. It's gonna be move to tile. I'm just gonna take a tile. New parameter, tile. Tile to move to. So what are we going to do? Pressed, we are going to get our current tile, get neighbors, find up. If we found some, okay, here's another thing about find. Finds value associated with provided key. So basically, if there's a value assigned to this key, it's going to return true here. However, that doesn't mean that there's always going to be a valid object assigned to that key. In up, it could be a null pointer and it will still return true. So what we're going to do is over here we're going to say it's valid instead of using this bool. So if it's valid, we are going to move to tile. And this is the tile to move to. I'm not going to copy and paste these yet because we're going to have to do a little bit more to this, but we'll get to that soon. What do we need? Let's just go to move to tile. So what we're going to do when we actually move to the tile, well, first off, just in case, we're going to say is valid again. And when we actually move, what we're going to do is we're going to make a timeline, add timeline. This is going to be our moves timeline. And what's going to happen is we're going to play from start. And during the update of this timeline, we're going to lerp from our current tile to our target tile based on how long the timeline's been going. So in our timeline, let's change the length. This is going to be how long it takes to move to another tile. I'm going to choose 0.2, and we're add a float. Add key, at zeros. It's going to have a value of 0 because we haven't started, and at 0.2, it's going to have a value of 1 because we've completed it now. So in our event graph, in our update, we're going to set actor location. Here we go. New location is going to be lerp vector. And start is going to be our current tile get location. End is going to be our tile to move to get actor location. And our alpha is going to be this new track 0. I don't know why I didn't rename it. Let's rename it. Over here, we can right click or rename. Call this move progress. There we go. That looks much better. let's test this really quick just so you can see what's going to happen. Press play, press up. Okay, so there's a couple of problems. First off, we never set our current tile to be our tile we want to move to after we're done moving. So on finished, we're going to set current tile. Wow, that did not go right. Set current tile, and it's just going to be a tile we move to. Compile and save this. You notice we can move up. Yay. However, we're not checking to see if we can actually enter. Also, if we hit up really fast, it starts over in this timeline. So we never actually hit finish and set the current tile to be our tile to move to. So what we're going to do to fix this is we're going to check to see if we can actually move. And to do that, let's make another variable. We're going to call this target tile. It's going to be tile. And we're going to set our target tile to be this right here. So instead we can go like that, make it a little less messy. And when we move, we're going to want to check first if our target tile is valid. Because if it is valid, that means we're currently moving. So we only want to move if it's not valid. Hit play. You'll see I can't do that. One more thing we need to do is we need to set our target tile to be nothing after we're done moving. And if I mash the up key, we only move after we've finished moving. Okay, still a little bit more over here we need to do before we can copy and paste them all. So let's also change our direction when we move. So we face the direction we're moving to. In our not tile map, player pawn, let's make another event. This is going to be rotate to custom event, rotate to direction, and it's going to take a direction. Direction to rotate to, and it's basically going to be the same thing as this. So is valid. Promote this to a variable. This is going to be target direction. Make a new timeline. Here it is. Add timeline. Rotate timeline. Length. I'm gonna actually make this a little bit smaller than our move time. I'm gonna make this 0.1 instead of 0.2. Just because I think it looks better that way. 0, 0, and 0.1 and 1. Rename this to rotate progress, so it's actually gonna finish rotating before we finish moving. And play from start. You always want to hit play from start, by the way, for these. Don't hit play, because play is just going to start at the time that it's currently at instead of from 0. And that's going to cause you problems. So on update, we are going to set actor rotation. It's going to be a lerp from our current rotation, or current direction, get rotation, to our target direction, get rotation, and shortest path to true. Finished, we will set our current rotation direction to be our target direction, and set our target direction to be nothing. And when we move, we are going to rotate 2 direction. For up, it's going to be up, and for the other ones, it's going to be, you know, the other ones. Let's copy, paste these now. 1, 2, 3. Sorry for the mess. Pressed, pressed, pressed. Move right and right. Down, down, left, left. Let's test this now. Hide this, press play. And that does not work. Moving works fine. Why is this not working? These are set properly. Move to direction is valid. Set target direction. Play from start. Set rotation. Ah, progress. There we go. Wonderful. Okay. Now let's make it so we actually check to see if we can actually enter the tile. So add a new function in our tile. It's going to be can player enter. We're going to need the player, player pawn, player, and we're going to need the tile we entered from. So tile, let's call this from. Let's return a bool can enter. The reason we're getting these inputs is just in case there's like some special stuff we want to do. Like for example, if the player has to have collected a key or something first, then we can enter. Or if we're moving from a certain direction, then we can enter or we can't enter. So in our wall, it's definitely going to be, we don't need to override it because we can't enter. However, in our ice, we need to override that function. Override can player enter. And we're just going to return true. I don't care which direction we're coming from. Oh, right. We actually have to move to tile. So before we set the target tile, we need to check to see if target tile.can player enter. Let's make this pure. So player is self, and from is our current tile. Branch, and only if we can enter do we bother doing this stuff. So now you can see when we try to enter the wall, nothing happens because we can't enter. Okay, one more thing to do. Well, actually there's a few more things to do, but you know, one more major thing to do. What we want is for the player to slide around until they hit a tile that either doesn't let them enter or doesn't force them to keep moving. So in our tile, we're going to make another function, new function. We're going to call this get next tile. This is going to be the tile we're going to go to next once we've entered this tile. So first variable player pawn, player, second variable is tile. This is going to be from. And we're going to return, make this pure, and then return a tile. This is going to be next tile. So once we finish moving, we're going to say if our current tile dot get next tile player self. If it has an X tile, then what we're going to do is we're going to set our target tile to be that tile. And at this point, if it is valid, sorry, used the wrong one, it's valid, then what we're going to do is we're just going to move tile again. So is valid, we're going to move to tile, and that's going to be our target tile. Now, for this from variable, once we've set our current tile, we don't know where we came from because our old current tile no longer is a thing. So to fix this, we're going to make a temporary variable. We're just going to call this temp. And we're going to set temp before we set our current tile to be our current tile. Because once we've entered the target tile, the tile that we've came from is our current tile. If that makes any sense. So back in our ice, we are going to override get next tile. Here it is. We don't care about our player, but we do care about where we came from. Alright? What we want is to find out which direction we came from, and we're going to move in the opposite direction. So let's show inherited values. Get neighbors, keys for each of these. If neighbors find, so we're going to find, we're going to go through all of our neighbors, and we're going to check to see if it's equal to our from tile, where we came from. So if it is, branch, that means we came from that tile, so we're going to get the opposite direction, get opposite direction, and we're going to find our neighbor in that direction. Find in opposite direction, and we're going to return this. Sorry, we're going to return, here it is, return this tile. And just to be safe on complete, we're just going to return nothing. Now let's test this. Press up, we keep moving. Whoa. And we cannot move again. Why is this? Go to player pawn. Set is valid, move to tile is not valid. We don't move to tile. Hold on, let me do some debugging real quick. Check our player pawn and move up. Shift F1 to get our mouse back. Our target tile is because okay, so when we move up, we keep moving up. When we're over here, we set our target tile to be the one above us because there is a tile there. So we're going to want to check to see if it's valid and if we can enter it. Can player enter, player self, and from is our current tile. Branch. Now let's try. We stop here and we can't move still. Can't enter. target is target tile. Yeah. Why is this happening? Oh, because we can't enter. Now we have to set our target tile. Sorry about that. Set target tile to be nothing so that we can move again. This should fix it. Yeah. See, now when I'm moving, when I'm pressing any directions, it won't let me move. It just keeps moving in that direction until we hit something. But if we go to our, let's make another tile type. Tile, create child blueprint. We'll just call this floor. This is going to be a normal floor that we can enter. However, it's not going to force us to move anywhere, right? So override, actually let's add a plane first before I forget. Override can enter, return true. Change tile type to be floor. Okay, press play. And I chose the wrong one. I meant to do this one. Change tile type to be floor. Ah. Now it doesn't force us to move anywhere. In case you were wondering, by the way, you can select multiple. You can hit Shift and click tiles to select multiple tiles, or you can hold on to Control Alt and left click drag to select multiple tiles. I forgot to mention that earlier, I think. Alright, one more thing. Sometimes we want our tiles to do stuff when we enter them. For example, you remember the button that caused the tiles to collapse, or the tile that we die on when we enter. So in our tile we're gonna need another. Well, actually, let's make this a event graph thing because we don't need it to return anything. So let's add custom event on entered. Once again, we need our player and we need tile they're coming from. Player pawn. Player from. And in our player pawn, we're going to get our current tile, and we're going to do on entered self and from is temp. And we're just going to do this at the end of any of these routes. No matter what happens, we're going to want to check to see what happened. We're going to want to tell our current tile that we entered it. So let's make another tile. Tile, new blueprint class, tile. Select. There's going to be lava. Let's make it a lava mat. Lava mat. Makes dark red. Hold on to 3. Click. Base color. Change this to be a really, yeah, like that. As you can tell, I'm an excellent artist. Very creative. Put a plane, change the material to be our lava mat. So, override functions can enter, return true. And we're going to override on entered. Let's just print string for now. We're going to call it, say, you died. I forgot to actually make it lava. Here we go. Change to lava, not floor, lava. Okay. Enter it. You see up there on the top left, you died. Here's a problem. When we die, we can still move around. So let's fix that. Let's make a let's make a boolean. We'll just call this can move override. Boolean. Here we go. and we're going to say if we can move, get branch. Okay. If we can move, then we'll do this stuff. We could put it over here at the move tile, however, we would still rotate in that case, so we don't want that to happen. Sorry for the people that copy and pasted up to this point. One more time. Well, 2 more times. Last one. Here we go. So in our lava, we're also going to tell our player can move override, set that to be false. Oh, we need to, the player needs to know that it starts with yes, we can move. And now I can't move around. Okay, how long has this video been so far? It's already been 1 hour and 20 minutes. This is getting pretty long, so I'm not going to bother showing how to do the rest of the stuff, but you know, you can probably figure it out on your own. There's no new functions to be added to either the player or the tile or anything like that. It's just custom stuff we add to on entered. And you know, we create widgets and set can we move, and for the button, what we did is finished. Here's the button. On our can move, we have a affected tiles variable on here, and we go through each of them. We tell them to fall. In the fall, what we do is we set is fallen to be true. They can only enter if it's fallen, and we do the same. We have a fallen timeline set actor location to be based off this timeline. Starts at positive 50, ends at negative 50. That's all the fallen pillar and the button do, really. I hope this helped. If it wasn't what you're looking for, I'm sorry for wasting 1 hour and 22 minutes of your time. But yeah, let me know if there's any questions or anything like that. I don't have a good way to stop this video, so I'm just gonna stop it now.